Okay, let's start our discussion now. So we're going to continue with this topic. So under this topic, we're going to look at the measures of dispersion for the ungrouped and grouped data set. So we're going to look at both of these. And then under this, we're going to look at the range, and then we're going to look at the variance and so on. Okay, so these are basically the topics that we're going to cover for today's session. And we're going to stop once we finish with all this one. Okay. Right. Okay, there's one more thing here. Instead of just range, we're just also going to look at what it means by IQR. So we have discussed the quartile before this, so it is good for us to also go through what it means by IQR. Okay, semua boleh nampak screen saya? Boleh? Okay. So let's continue. We're going to start with the measures of dispersion for ungrouped data and also for the group data set. We're going to do it first, and these are the data that we're going to use in order to perform our demonstration on how to calculate all these values. So the first one that we're going to look at is range. Okay, before that, let me just give you some idea what it means by measures of dispersion or measures of variation. Okay, previously we only looked at a point estimate, whereby we only deal with the calculation of the measures which relate to only a point. Okay, for example, let's say kita tengok yang mean before this. So mean is just a point. So it's just a point estimate that gives you a summary of a whole data set, right? But we don't know much about the distribution of the data set. We don't know much about how the data behave between one another. So is there any variation between one variable with the other? If there is a variation, what kind of variation that you have? Is it they are farther away from one to another, or is it they are close together, right? So this is the things that will be discovered by the measures of dispersion or the measures of variation, whereby the measures of dispersion will identify or will determine the distribution of the data set such that it covers the ideas of looking the distance between one variable with the other. And of course, sometimes they will be using certain reference point for the distance. Okay, but in this sense, basically when we talk about dispersion, we are looking at how the data behave towards one another. Are they close together or are they farther away from one to another? Okay, so which means that if they are close together, that means they has a lower dispersion, so lower variation, because the values are almost identical. All right, so it doesn't make so much difference between one variable with another, so they are clustered together. However, if you have a larger dispersion, means that the data is farther away from one another and the cluster is bigger. Okay, the cluster is bigger. For example, in this situation, let's just I get my pen over here. Okay, suppose that you have a data set that is close together, so you have a value something like this. Okay, so this value are close together, so the cluster is a bit small. However, if you have the same data set but it is farther away, so they are farther away, and it looks like the cluster are bigger. So in this sense, you can say that this is less dispersed. So this is a less dispersed, and this is more dispersed. Okay, so when we talk about more dispersed, that means they have a larger variation between one another, but this one is less dispersed. they have a smaller variation between one another. And normally the words dispersion here sometimes also uh, being used together with the term consistent. Okay, we'll use together with the term consistent. So what is the relationship between dispersion and consistent? Normally when we have a less dispersed data set, that means the data is more consistent. So consistent meaning to say that they are not farther away from one to another. Okay, they are consistently almost the same values. So for example, let's say I took students taking an exam and their marks is not so much different, so they are clustered together. So that means their marks are more consistent compared to the one with the larger dispersion. Okay, so that is basically what it means by dispersion, what it means by variation. So we are looking at more detail instead of just looking at one values like we did before in calculating the values for the mean, median, and mode, and also for the quartile. That one is just basically we are looking at a point estimates. Okay. Okay, so now we are looking at a larger picture. Okay, one way to look at the variation between variables, okay, in a data set, variation in a data set or dispersion in a data set is through the measures of the range, okay, through the measures of the range. So the range is simply the difference between the largest value with the smallest value, okay, the difference between the largest value and the smallest value. In this sense, we just need to locate the largest value and the smallest value. For example, in this case, suppose that you have this data set, the following stem, this is not a stem and leaf, okay? So because this one is actually the actual question, they give you the stem and leaf. So this one I just want to, let's see. Okay, I just want to change this one, so this is not stem. The amount spent by 20 UiTM students who made purchase at the bookstore. Of course, you can come up with a stem and leaf over here. So kalau you nak come up with a stem and leaf, kalau you still recall, so let's just do it very fast. The stem and leaf for this one. So if let's say you want to draw a stem and leaf here, so you know that you have the stem and also the leaf, right? So since this one is already in ordered, you know that the stem will be 2, 3, 4, 5, 6, 7. Okay, and then you have the values to be 5, 6. You have 0, 2, 3, 4, 5. So 0, 2, 3, 4, 5. And then you have 50, 0, 2, 4. So this one is 0, 2, 4. And then 7, 7, 7, 9. So you have 7, 7, 7, 9. And lastly, you have 3, 4, 5, 6, 8, 9. Okay, so that is the stem and leaf. Okay, so I get this data from the stem and leaf like this. So it's transformed into a raw data set. So in this case, if you want to find the range for this particular information, okay, you have the range here to be the largest minus the smallest value. So in this case, the largest value is 79 and the smallest value is 25, right? So this is the largest, and then this is the lowest. Okay, so that means you just need to take the largest minus the lowest. So in this situation, it will be 79 minus 25. Okay, so you get this to be 454. So you get this to be 54. Okay, so 54 what? So in this case, this will be 54 ringgit lah kan. So RM 54 lah. But this one is the amount spent. So that means RM 54 ringgit. So this is the range, right? So what does this tells you? This tells you that the students spend between 25 to 75 9 ringgit, which is the span of 54 ringgit difference, okay, from the largest to the lowest. So in this case, kalau you perhatikan dekat sini, the range is not robust. Okay, range is not robust. So this one is not robust. Okay, not robust, which means that so it is affected by outliers. Okay, it is affected by outliers, or in this sense, bila katakan outliers maksudnya affected by extreme values lah. Okay, kalau ada extreme values, that means dia akan dipengaruhi oleh extreme values, right? Okay, sebelum saya teruskan, saya nak mohon those yang ada dalam ni tolong tulis nama you all dalam bahagian chat, Okay, mohon untuk tulis nama dalam bahagian chat. So kat sini ada 11 pelajar saja. So saya minta untuk 11 pelajar ni tulis nama anda dalam bahagian chat. Okay, so let's continue. Alright, so let's continue with our session. So just now saya dah katakan, so this will be the is not robust, so that means it is affected by the extreme values. Okay, so when it is affected by extreme values, so that means if you have a value that is too small or too large, then the values of the range will be different, right? For example, in this case, suppose that instead of 179 here, it becomes 179. So if 179, now you're gonna have this to be, let me just get a different color. So let's say you have here, instead of that one, you have 179. So now if you have 179, so your range will be 179 minus 25, right? So this will be 154. So you can see that if there exists an outliers or an extreme values, then the range will be affected. Okay, this is the same case like what you have in mean. So dalam mean pun sama juga kan. So mean kalau kita ada satu nilai yang terlampau besar ataupun terlampau kecil, maka nilai mean tu akan di-pull towards the extreme values. So same thing over here. So bila kita ada range yang bila kita ada extreme values, the range value also will be pulled towards the larger value. Okay, dia akan jadi lebih besar lah. Okay, it's always be much greater than the actual one. So that's why when this thing is not robust, So in order to make comparison between groups, you must make sure that there exist no outliers. Otherwise, you cannot compare between groups using range. Okay, tak boleh compare using range. And one more thing, bila you nak buat comparison using range, then the comparison or the data set must be from the same unit. Okay, you tak boleh nak buat comparison width dengan height. So they are in different unit. So you cannot make the comparison. Okay. So in this situation, the comparing groups using range is limited due to certain criteria. If they have no outliers and they have the same unit, then you can make comparison between two groups on their dispersion, which one is more consistent, which one is less consistent. And of course, the one with the lower values of range, it is more consistent, ataupun kata lain, less dispersed. Alright. So tapi kalau katakan ada extreme values, you tak boleh buat comparison because it will be misleading. Okay, contoh macam ni tadilah. Okay, kalau katakan asal just 54, tiba-tiba dengan adanya range, dia jadi adanya extreme value jadi 154. So you pun kata, okay, this group is more dispersed, sedangkan the higher value of range is only because of there is one extreme values. Itu yang kita tak nak, so kita tak boleh buat macam tu. Okay, so that is for range. And then you can also calculate what we call as the interquartile range. Okay, kita boleh juga kira interquartile range. So what is the interquartile range? So basically when we talk about interquartile range, so interquartile range is simply the difference between the upper quartile with the lower quartile. So upper quartile dengan lower quartile ni. So upper quartile ni adalah Q3 and lower quartile is Q1. So last time we have looked through how we can calculate the quartile measures of position, right? So how we can calculate the quartile measures of position, and from there you can identify. Okay, you can identify the quartile 3 and quartile 1, and basically with these two values you can calculate the interquartile range. Okay, so the interquartile range basically give you the 50% of the main body of your data set. So kenapa saya katakan 50% of the main body? So this give you 50% of the main body, main body of the data set. Okay, kenapa 50%? Because before this kalau you tengok kita dah buat Q1, Q3 kan. So what is Q1, Q3? So basically bila kita tengok pada Q1, Q3, saya turunkan yang ni sikit. Okay, when we talk about Q1, Q3, you can see that before this we can draw the distribution where you can divide the quartile into 3 quartiles, right? Into 4 quarters, and then you have 3 quartiles. So you have Q1, you have Q3 over here. Okay, and between these two groups, this Q1, Q3, this area, the middle area here, is actually the 50% of your data set lie inside here. So your 50% is in this data set. Okay, it's in the middle. So that's why we call this as 50% of the main body. Okay, so when you calculate the interquartile range, the smaller the interquartile range, the less dispersed the data will be. Kenapa macam tu? Kalau kita compare, okay, let's say we compare these two graph. Okay, these two distribution. Satu macam ni. So this is Q1. This is Q3. Okay, compare dengan yang the left side. So if you look through this one, which one is close to one another? Gambar rajah mana yang memberikan kita gambaran bahawa data tersebut berada dekat antara satu sama lain? Of course, this will be more consistent, right? Okay, sebab apa saya katakan yang ni lebih konsisten? Sebab data dia lebih dekat antara satu sama lain. Kenapa dia lebih dekat antara satu sama lain? If you look through the area under the curve, this area is smaller, but this area is bigger. So, dia macam kita masuk dalam satu kelas lah. So, katakan kita ada 20 orang pelajar. Kita masuk ke kelas yang kecil. Contohnya, kita masuk ke kelas B1 contohnya. Okay, kita masuk ke kelas B1, ke kelas yang kecil. So, kita akan berada dekat dengan satu sama lain. Tapi kalau 20 orang tu kita letakkan dalam Dewan Sarjana, contohnya, yang lebih luas, maka pelajar-pelajar ni boleh duduk jauh antara satu sama lain. Dia tak adalah dekat satu sama lain kan. So, inilah analoginya. Kalau katakan Q1 dan Q3, the interquartile range ni, okay, this is the interquartile range, IQR. Okay, if the interquartile range is smaller, that means the data is more consistent, which means that they are close to one another because they have a smaller area with the same amount of data set with the other one. Okay, so katakan kat sini ada 100 data, kat sini pun ada 100 data, tapi yang ni 100 data ni dia terserak dengan lebih besar serakan dia sebab kawasan dia besar. Tapi yang ni dia terpaksa berhimpit-himpit lah sebab kawasan dia kecil. Contoh macam berhimpit macam sardin dalam tin lah kan. So macam tu. So dia dekat-dekat. Tapi kalau katakan kita buat botol sardin, tin sardin tu besar tapi amount yang sama, maka dia boleh duduk jauh-jauh sikit. Tak adalah dia bersembang dalam tin tu. Okay. So dia kurang macam tu lah kan. Alright. So that is the situation where you have the interquartile range. So in this situation, you can use the range or interquartile range to compare between groups. Okay. The interquartile range will give you a better idea from the range because interquartile range normally is not affected by outliers because this is a measures of position. Unless there exists any changes in position, when you add up values, then it will change. Otherwise, if you have outliers, it won't change the Q1 and Q3 values compared to range. Kalau katakan outliers, nilai range memang akan berubah. Tapi dalam interquartile range, even though you have an outliers in your data set, the Q1 and Q3 will not be affected, and at the same time the IQR also will not be affected. Okay, so that is the situation. Alright, so in terms of the choice, if you want to make comparison for consistency, if you have two values, range and interquartile range, it is better for you to use interquartile range because if there is no outliers, then interquartile you can use both. But if there exists outliers, interquartile range will be much better compared to range. Okay, this is another way of getting the variations. Okay, so the next one that we're going to look at is what we call as variance. So of course, if you cannot use both of these to make comparison, another way is by using what we call as a variance. Okay, what is variance is all about? Okay, if you are talking about range and interquartile range, there is no certain reference point being included in your measurement. Okay, there's no reference point. But when you talk about variance, we added one more information where you put in the reference point for you to calculate the dispersions. And in this situation, the reference point is your mean value. Okay, so basically when we talk about variance, it just simply means that the variance is a numerical measure of how the data values is dispersed around the mean. So dia ada perkataan mean kat sini. Okay, so maksudnya kat sini variance ni dia melihat bagaimana data terserak, serakan data tersebut respective to the position of the mean. Okay, respective to the position of the mean. So kita tengok macam mana dia punya nilai tu. So macam mana dia punya serakan, reference dia adalah nilai mean. Okay, berapa jauh. So we are calculating the distance between a data set to the mean. And then kita averagekan dia. Okay, so what is the formulas for the variance? So of course for the variance, this is a numerical measures, and it can be for the population and also for the sample. Okay, what is the difference between the formulas for the population and the sample? Of course, in terms of the symbol use. Okay. Okay, you can calculate the sample variance. Okay, before we go for the sample variance, let's see what is the formula for the population variance. Okay, the population variance will be denoted as sigma squared. Okay, sigma squared, whereby this is given by 1 over capital letter N. So we use the capital letter N because capital letter N referring to the population size, and sigma, the Greek letter sigma, referring to the variance, sigma squared referring to the variance of a population. Okay, and then you multiply with okay, you multiply with the summation of the difference between the x value, the data's value, with the population mean. Sorry, so we need the population mean population. Okay, you have the mean population. Okay, minus the mu. Sebab kita gunakan populasi and then we square this value. Okay, so this is for the population because you are using all the parameter values, so all the notation for the parameter, sigma squared, capital letter N, and then also the mu. However, for the sample variance, okay, since this is a sample, we estimate, okay, we are estimating the sample variance for the population. Okay, so the sample variance is given by the formula S squared is equal to 1 over n minus 1. Okay, why n minus 1? Because in this situation, this is what we call as degrees of freedom. So we lose 1 degree of freedom when you calculate the sample variance. Why do you need to minus 1? So kenapa kita lose 1 degrees of freedom? The degrees of freedom, we lose 1 degrees of freedom whenever we estimate a value from the sample. So in this situation, if you want to calculate the sample standard variance, or the sample standard deviation, you need to first estimate the value of mean, the sample mean. So that is why when you estimate one statistics, you lose 1 degrees of freedom. Okay, so that is the reason behind that, right? So in this case, it is also given by the same formula. So you have summation of But right now you have xi minus x bar. Kenapa x bar? Sebab kita gunakan sample. And in general, you can also rewrite this formula with the formula 1 over n minus 1. Okay, 1 over n minus 1. And then you multiply with the summation of x squared minus the summation of x, the whole thing square divided by n. Okay, so why do you need this formula? Because the second formula here, you can use your calculator directly to calculate the standard deviation or the variance. Okay, you can use the calculator directly. But if this one, you have to come up with the table with you have to find the mean, and then you have to calculate the difference and square them. Of course, you still can use the calculator, but it will be troublesome rather than using this method. Okay, how to use the calculator for this particular example, for this particular formula, you can look into you can go into my YouTube channel and look at how it is applied. Okay, all right, so that is the formulas for the variance. Later on we're going to see how we can apply these formulas, but before that we just go to what it means by standard deviation, right? So what is standard deviation? Standard deviation is simply the square root of the variance. Okay, so I'm just going to write down the formula for the sample. So in this case, it is denoted as S only. So this is the sample standard deviation, and this is simply the square root of the variance. So in this case, it's just the square root of the S square. That's why you have S. So that means if you want to find the standard deviation, if you want to find the standard deviation for a sample and you already calculated the variance for a sample, you just need to take the square root of that particular variance. Okay? Alright. And then vice versa. If you already have the standard deviation, to get the variance, just square them. Okay, so this is for the ungrouped data. Okay, what about for group data set? How are you going to come up with the formula for a group data set? Okay, so in this situation for a group data set, you just need to add F in front of the X. So for group data set, okay, yang ni untuk group So untuk group, so it will be 1 over n minus 1 and then multiply with summation of fx square minus summation, fx, summation of fx square divided by n. Okay, you just kena tambahkan summation f kat depan tu Okay, that is for the group data set. Okay, let's look at how are we going to compute the variance for group and ungrouped data. Okay, consider the above data set. So kita akan consider these two data set. Okay, let's see how we can calculate the variance. Okay, for the ungrouped data set. Okay, the first thing that you need to do for ungrouped, so kita consider example yang ni. Look at this is question 1. This is question 2. Okay, look at question 1. So, okay, let's look at data from question 1. Okay, we look at data from question 1. So data from Q1. Okay, so we got data from Q1. So what you need to do first is, because the formula require you to get the mean. So if you want to use this formula, then you have to find the mean first and then take the difference, and then barulah you kuasa duakan. Okay. But if you don't want to find the mean, so if you don't want to find the mean, you can also use this formula where you calculate the summation of x and summation of x squared. So what it means here, to calculate the summation of x is simply you get the summation of x. So this is simply equal to add all the values. So 25 plus 26, okay, and then plus 40 plus until what you have here 78 plus 79. So you get the answer over here. Later on we will calculate this one. And the next one is to calculate the summation of x squared. So what you need to do is just simply square the values of each of the data set and add them together. Okay, dan seterusnya lah. Okay, sampailah you dapat 79 square, so you get the answer over here. Okay, so let's do this very quick. So saya akan buat dekat calculator saya. You just need to follow through. Okay, you just need to follow through the steps. Kalau nanti you all boleh tengoklah video yang saya tunjukkan. Sebab tadi saya tertunjukkan saya punya calculator lah. Okay, I won't be showing you the calculator. Saya akan buat dekat dalam calculator. I just gonna explain. You just listen and try to do the same thing with your calculator at your place. Alright. Okay, in order to perform this analysis, to perform this calculation, you need to change your calculator mode into SD mode. So you press the mode button until you find SD and choose SD. Okay. Okay, the next thing to do is to key in the values. So in order to key in the values, you just need to key in the values and then store it by pressing the M plus button. Okay, you key in and then store by pressing the M plus button, and you repeat until the end of the data. So I will do this now. So you have 25 M plus, 26 M plus, and then 40 M plus, 42 M plus, 43 M plus, 44 M plus, 45 M plus, 50, 52, 54, 50, 52, 54. And then the next one you have 67, 67, 67, 67, 67, 67, and then 69. Finally you have 73, 74, 75, 76, and lastly 78, 79. Okay, you have 20 data in your data set. So once you have keyed in all the values, you need to find the summation. Okay, so what is the summation values over here? Where is my cursor? Okay, what is the summation values right now? So you can find the summation values. Okay, so now the summation values. To find the summation values, you just need to key in, press shift number 1, and then it will give you an option, something like this. So when you shift number 1, so it will display summation of x squared summation of x and then n. So this 1, 2, 3. So you want the summation of x, you choose number 2 and then press enter. Okay, press equal sign, so you get 1146. So here you have 1146. And then to find the summation of x squared, again repeat the same process. Shift number 1 and then choose number 1 and then press the equal sign. So you get 71,354. Okay, 71,354. Right? So once you have this thing, so the next thing to do is to substitute this value into the formula. So how to substitute the formula? So you can just use this formula because this is ungrouped. So gunakan yang ni boleh sebab kita dah ada nilai summation of x dengan summation of y. Sorry, x dengan x squared. Right? So substitute into the value. So you have this to be s squared equal to 1 over n minus 1. So n is 20 minus 1, right? And of course, in the exam, practice the correct problem solving. So the correct problem solving is to write down the formula first. Bila you nak tuliskan jawapan, So tulis formula dulu, barulah substitute. Remember, in statistical or mathematical problem solving, the first step that you need to do is to identify the given information or compute whatever information needed. And then the second one, state the correct formula to be used. So kita kena state kan. So kita kena tulis And then the second one, substitute the values into the formula. And then last kali, evaluate and obtain the result. So in this case, sepatutnya kita kena tulis dulu lah formula So let me just write down the formula first. Okay, you have to write down the formula first. Okay, so the formula is 1 over n minus 1, and then you use the second formula, that is summation of x squared minus summation of x squared divided by n. And then in this situation right now, kita kena gantikan dengan nilai. Okay, so we substitute the values, so you get this value. So you have 1 over 20 minus 1 and then multiply with summation of x squared is 71,354 minus and then 1146 square divided by 20. Okay, so you can calculate this manually or you can find using your calculator. You just need to press shift number 2. Okay, when you press shift number 2, it will give you 3 options, that is x bar, and then you have sigma x and sx. So 1, 2, 3. So yang mana kita nak pilih? So kita pilihlah yang ketiga ni So yang ketiga, tapi this one is actually the standard deviation. So you want the variance, so that means you have to take the square. So we choose number 3. And then before you press the equal sign, you must square it. Okay, just press the square button and you get sx square, and then barulah you tekan sama dengan. So you akan dapat for this one is 299.38.4 lah Okay, 299.4. So this is what? So this is RM. Okay, the variance is 299.4. Okay. What about the standard deviation? So the standard deviation is simply take the square root of the variance. Okay, the standard deviation, if you want to find the standard deviation, so S is just simply the square root of S squared. And this is just simply taking the square root of 299.4. So this give you, kalau kata kat sini, shift number 2, number 3, 17.3. Okay, 17. Okay, you get the values to be 17.3. Okay, again, RM. Alright, so that is for the ungrouped data. Okay, this is for the ungrouped data. Alright, so and then you bolehlah compare. So you can also compare groups with the ungrouped data with the standard deviation. Normally we use the standard deviation to compare the data. Sorry. Okay, to compare between two or more groups of a data set. Okay, so you boleh buat comparison menggunakan standard deviation, and the same thing, the lower value of the standard deviation will give you a less dispersed data set. Okay, so that means it is more consistent if you have a lower standard deviation. Okay, so that is the situation. Yeah. Okay, so that is for the ungrouped data. So itu adalah untuk ungrouped data. So just now saya katakan kenapa dia nilai yang kecil lebih konsisten. Just look at this comparison. So when we talk about standard deviation, since variance is actually variance and standard deviation, they are actually a reference towards the mean values. So suppose that you have a distribution like this, and then you have the mean. So mu is over here. Okay. So when you have the variance or the standard, we use the standard deviation in this situation. You can have mu less than 1 standard deviation or greater than 1 standard deviation. Okay. So in this situation, you're gonna have, let's say, 1 standard deviation over here. So this is minus 1 sigma. Okay, this one will be plus 1 sigma. Okay, 1 standard deviation dengan within 1 standard deviation. So in this case, mu plus or minus 1 standard deviation. So this is called the interval. Okay, so in this situation, this area comprise of 68% of your data set. Okay, so that means if you have a smaller standard deviation, then the area here will be much smaller. Okay, the area will be much smaller, but the amount of data set reside in that particular area must still be the same, that is 68%. This is for a normal curve, normal symmetrical distribution. Okay, 68% of the data set will lie between 1 standard deviation. Meanwhile, 95.4% of the data will lie between 2 standard deviation. Okay, kalau 3 standard deviation, it will be 98.8%. So almost 100% lie within the 3 standard deviation. So anything outside the 3 standard deviation can already be considered as outliers. Okay, so can already be considered as outliers in a normal curve. Okay, that's why in this situation, bila kita nak compare menggunakan standard deviation ataupun menggunakan variance, so normally kita tak guna sangat variance, kita gunakan standard deviation. So we look at a smaller standard deviation to determine whether is it consistent, more consistent or less consistent. Okay, the one with the lower standard deviation will be more consistent compared to the one with the higher standard deviation. Okay, so that is for the concept of using standard deviation in making comparison between groups. Okay, so next we're going to look at how we're going to calculate this information for group dataset. Okay, kita tengok pula untuk group dataset. So yang ni kita nak tengok untuk group dataset. Mana saya minta ni? Saya tak naik. Hang ke? Sekejap Macam hang pula. Sekejap. Salah. Sekejap saya punya screen tak naik lah pula Tak tahu siapa. Hold on. Why is it tak naik? Hold on. Okay, naiklah. Okay, so let's look at the group dataset. So I will be using this dataset. So let's see this one. So kita akan tengok yang ni. Ya, masa tak keluar. Okay, for group dataset, so if you can see this one, so I will just explain. So apa yang perlu anda buat untuk group dataset. So for group dataset, you have this kind of situation. So you have this data. Okay, you have the weight of 100 harum manis basket created from farm B is shown in table below. So you have this table, and then you have basket. So group of baskets, so ada 131 and to 140, 141 to 160, and also so you have 13, 20, and the frequency. So basically, when you want to calculate the standard deviation for the group data set, first of all, what you need to do is to find the midpoint. Okay, you need to find the midpoint of your data. So let me just try to figure out why this is not working. Saya tak boleh main. Okay, dia keluar dah. Okay, saya akan tunjuk sekejap. Tunggu sekejap saya tunjukkan dia punya pergerakan tu sebab dia tak boleh nak display kat situ. Saya just bagi give me 2 minutes to calculate all this value. Sekejap eh. Only 210. And X. Okay, sekejap eh. Alright. Siapa tak keluar ni? Sekejap eh, dia tak keluar lah. I have no idea kenapa tak keluar. Dah edit. Sekejap eh. Tengok lagi. Kenapa tak keluar ni? Okay, alright. Okay, keluar dah eh. Okay, so this is the data eh. So tadi yang kita dapat tadi. Okay, in order to come up with the for the group data set, so in this situation you have the values in the form of group data. So we have a number of basket in a class limit form. So we have 121 until 140. So in order to calculate the standard deviation and also the variance for this group data set, the first thing that you need to do is to find the midpoint. So the midpoint here is x. So to find the value of x here, what you just need to do is to simply add the lower and the upper values for each of the classes. and then divided by 2. So for example, in this case, you add 121 to 140, and then divided by 2, you get 130.5. So this will be your point of reference for each of the classes. Okay, so this representing the midpoint. Okay, the midpoint of each of the classes, and this midpoint will be referring to the x. So that's why under here, kalau you tengok kat bawah ni, kita ada formula kita summation of fx. So we have the summation of fx. Alright, so we have this one, right? So kita ada yang cos fx ni. So sebab tu kita ada nilai x kat sini. So kat sini tak ada nilai x, sebab nilai x ni dalam bentuk selang kelas, right? So we have to find the value of the midpoint first. So this is the midpoint. Okay, once you have find the midpoint, then the next thing to do is to find the summation of fx. So the summation of fx is simply this is the fs. So yang ni adalah dia punya f, dia punya frequency. You multiply the frequency with the value of x, then you get the value here. So for example, in this case, this one is you get 13 times 130.5. So you get fx equal to 1696.5. Okay. And then the next column here will be the summation, the fx square. So bear in mind here, the fx square is actually, the square is only for the x. Hanya x saja yang kita kuasa duakan, bukannya the whole thing. Some students will calculate this one using this thing. So dia akan ambil 1696.5, dia kuasa duakan. That is wrong. Okay. The correct way is to multiply 13 with 130.5 square. So the only thing that square is 130.5. So in this situation, this part is calculated based on 13, and then you multiply with 130.5, and then this one is square. Okay, bukan yang 13 ni square. So hanya x saja yang kita kuasa duakan. So kita akan dapat this value lah. Okay, meanwhile yang this one is only 13 multiply with 130.5. Tu je. And then we do the same thing for the rest of the data, for the rest of the classes. And then at the end here, you calculate the sum. So this will be your n, ataupun summation of f. So this one tak ada apa-apa. So this one just discard. So this tak ada. So kita tak perlukan yang ni. Jangan confuse. And then this one kita akan dapatkan dia punya summation of fx. And this part is actually the summation of fx squared. Okay. So once you have this value, then you can substitute in the formula. So the formula says that s squared is just equal to 1 over n, n minus 1. So that means 99. And then multiply with, this value is 291.0885, 0885, and then minus, you have summation of fx divided by ns. So summation of fx is 16910 square, and then divided by 100, and then tutup kurungan. Okay, when you calculate this one, you should get the answer. So kalau kita kira yang ni, kita akan dapatkan 16910 square divided by 100. So you get 2859. So take 291.0885 minus the answer just now. So you get 26251, and then divided by 99. Okay, you will get this to be 269. Is it correct? Tulis lagi lah. Dah 169 6910 square divided by 100. Okay, betul. And then 291,0885 minus answer 51, sorry. So you can divide by 99. So you get 519. So over here you get 519. So you get here to be 519.23. Okay, so this is the standard deviation, the variance. And then to find the standard deviation, so S is just simply taking the square root of 519.33. So this gives you 22.79. Okay, 0.787. Yeah. Okay, you get 22.787. Okay, so this will be your standard deviation. Okay, this will be your standard deviation. So this referring to what? 22.787 is referring to the number of basket. Okay, referring to the number of basket, right? So this will be 22.787 basket. So that means this one is also 519.23 basket, right? So this will be the sample, this variance, and this one will be the sample standard deviation for the group data set. So this is how you calculate the standard deviation for group data set. So just now kita tengok untuk yang ungroup, dan satu lagi kita tengok untuk group data set. Okay, any questions so far?